So we're here to talk about end-to-end testing, and I'm here to present what UTAM is. UTAM stands for UI Testing Automation Model. And I'm Philippe Ozil. I'm a developer advocate at Salesforce, and this wonderful piece of technology called UTAM is something that we develop at Salesforce. Before I jump into the presentation, I want to thank all the sponsors who made this event possible. It's so cool that they are investing in this great community event. I don't know if in the room you're familiar with end-to-end testing. Can I have a quick show of hands, see how many people are familiar with it? Yeah? Oh, well, quite a few people actually. I'm talking to a crowd of experts. This is kind of unusual because normally people don't really know what this is. So anyways, I'm still going to do some level setting. I'm going to talk very briefly about what end-to-end testing is. And I will talk more about UI testing, and then I'll move into more technical things. I'll present UTAM, and we'll see some examples of how you can use UTAM to run end-to-end tests. All right, let's get started with a quick refresher on what is end-to-end testing. You've probably all seen this if you've been doing a bit of computer science. Testing can take multiple forms and shapes, and there are different types of tests we need to run. So quick refresher on the types of tests. At the bottom of the test pyramid is our so-called unit tests. Here today we're looking at more front-end user interface part. So there are unit tests even for the front end. And when you work with Salesforce, you probably know already the Apex unit tests, but you also have unit tests for the front end. These are not mandatory, but highly recommended. So for example, if you work with technologies like Lightning Web Components, you have to work with a technology called Jest to run unit tests for your Lightning Web Components. And UTAM will go further than this, but generally we highly recommend to invest a lot in unit tests because unit tests are fast, they're quite efficient already at detecting bugs, and so this is something you should heavily invest on. But there's a second level. In addition to unit tests, there's an additional level of complexity when you start integrating and working with external systems. Say, for example, your code talks to a web service, or you have to access a database. So it's no longer only your system at this point, you're dependent on other systems. And to work with these kinds of tests, this is no longer units, it's called integration tests. And the reason why it's called integration tests because it's talking with other integrations, other third-party systems. And even within Salesforce, you already have third-party systems in the end. When you already start talking with, for example, a third-party library, maybe like a package, this is already some sort of integration. And it gets even more funny now because when you start working with packages again, you don't necessarily have the source code of this integration. So sometimes it can get a bit tricky to test with integrations. Finally, like the simplified pyramid, there's a last top level, which are end-to-end testing. And what does it mean? It means basically that you run a test from the beginning to the end of a business user's interaction with the user interface. So it generally involves a lot of clicking, navigating in the application, even logging in the application. This is what we call end-to-end testing. So this is designed to be the closest as possible to what the end user will be doing when they'll be working with your application. And it includes different types of subtests. So I didn't go through the details, and some people can be a bit picky about the terminology here. But end-to-end testing is not just UI testing. There's the automated part, which is UI testing, but there are also functional tests in which you'll have testers who will be actually clicking around. So generally, it's better when you can put a bit of automation, but there's a little problem with end-to-end testing. It's generally expensive and fragile. It's very hard to automate all of these things because there are a lot of parameters or things that can change. For example, say if you build UI testing automation, it will rely heavily on the structure of your pages. And there are a lot of things that can change. I mean, there's your source code, but there's not that only. There's the Salesforce release, which can change. Maybe you have also dependent packages that may be updated separately. So there's a lot of factors that can slightly change a bit your interface and that can break all of these UI tests. And we'll see about how UTAM can help you bridge a bit the gap and bridge the gap and make those tests a bit more robust and easy to maintain. I want to remind you of one best practice. I'm talking here about end-to-end testing, but never lose focus about the fact that the best practice is to do something called shift left, or actually it's more shift down when you look at the test pyramid, is always invest first heavily in unit tests. The other types of tests come after. You want to have the more unit tests as possible, but a lot of integration tests, and in the end, a couple of end-to-end tests. But it's always more efficient to detect bugs and to catch issues, the lower you are. It's going to be less expensive, and the early enough you detect issues, the easier it is to solve them. Because when you're working with end-to-end, it's already a bit too late. You have to catch up and apply changes later on in the chain. Yes, I have already a question. Can you pass the mic behind, please?
Sorry, I'm really new to the world of testing and I need to improve myself. When you say lower and higher on the pyramid, can you just spend 30 seconds just explaining, is it more impact that you have to just do more tests? What does it mean? Sorry, a really basic beginner question.
These are different scopes of tests. So essentially, unit test is something that you run single-handedly on your own developer machine. It's very easy. It's very small. It's just, for example, a function. The coverage in terms of lines of code is very small. You're testing maybe 3 lines of code, 5 lines of code. But the higher up you go in a pyramid, the more code volume you test. An integration will test more than one system. It will cover hundreds, thousands of lines of codes. And the end-to-end testing covers the entire application. So the complexity and the scope of the test just keeps on increasing. And as do the error cases, the possibility of errors also gets higher when you get to end-to-end. So that's the test pyramid. Now we're going to really focus today on end-to-end testing. And as I mentioned, it's a bit expensive and fragile. And that's the purpose of UTAM, is to actually make things easier on the testers, or on people who are developing those end-to-end tests. And how does it change the game? Well, there are a number of things that UTAM introduced to break a bit the complexity. I mentioned earlier that this is an open source tool that is built by Salesforce, but I want also to mention the fact that it is something that we also use internally. When we test the user experience, for example, line experience and stuff like that, internally at Salesforce, we also use our own tool. We use UTAM. And it's been developed for a couple of releases already. We've just open sourced it. It went GA with this release. And it's really powerful, and that's something I really love. It is not an end-to-end test runner. So UTAM alone will not solve the problem of end-to-end testing. It is coupled with an end-to-end testing runner. There are a number of solutions on the market. For example, there's a famous tool called Selenium. And in the case of UTAM, we provide examples for another technology that is more open source, but it's called WebDriver.io. And this is the demo I will do in a couple of minutes. I'll show you how we can use UTAM with WebDriver.io. So how does UTAM address the complexity of building end-to-end tests? Well, it simplifies the test by making them more robust. And the key thing here is that it breaks large tests into smaller chunks. And it relies on a concept called page objects, which I'll explain right now. So when you build some tests, you generally have a page that you want to test. It can be, of course, one page or multiple pages. Generally, when it's end-to-end pages test, it covers multiple pages. But for the sake of the example, I'm going to take, but we test only one page. Now, our page is rendered in the browser. And so in order to test it, we need to get access to the page content. And one of the easiest way to do that is to look at the structure of the page, the DOM tree, the HTML structure of the page. And with UTAM, what we do is that we create something called page objects. Page objects are pretty much a mirror of components. When you build a page with components, they're modular and they're composable. So you would have one page object for the top page, but it will be decomposed in sub-pages, sub-page objects, sections, down to the smallest level where we have individual components. Each page object is written in JSON, and they reference a specific element in the page that you're looking at. And they can also reference parents and children, pretty much like the DOM would do. What is really powerful is that it's very simple to write. It's just JSON here. There's no code involved at this point. And the power of UTAM is that it will transform these JSON page objects into programmable objects. So it will compile those page objects into multiple languages. UTAM has support for 3 languages right now. It supports JavaScript, TypeScript, or Java, so you can write your end-to-end tests in language of your choice. But it also starts with just JSON. And once you transform this JSON into classes or objects that you can manipulate, you can then plug in your test runner. So WebDriver.io or Selenium again. And these test runners will use the generated objects from UTAM to run your tests. Now, the beauty of all of this is that the test itself, the test code here in orange here, does not know about the structure of your page. There's no mention of CSS in there. So it is totally decoupled from the actual page itself. And when you run a test, the test runner will just manipulate the UTAM page objects to control the page with the browser. And that's actually solving one of the biggest issues with end-to-end tests, is that normally they're full of CSS references. So each time the page structure changes, well, you break all your tests and you have to go through all of your tests to update maybe a little dash somewhere in your class name or something like that, and you have references all over your code space for those tests. With UTAM, it's way simpler. You have a single page object that is referenced in multiple tests. You just fix it once, regenerate the source code, and then you can run again your tests. And we're going to see that with some examples. So let me just quickly take a break from the slides, and we're going to head over to the UTAM website, which is, I think, a great resource to get started with UTAM. So I had all of this prepared before, but since we had a little issue with the monitor, I had to reopen all my tabs. Bear with me for a second. Oh, it's not showing my screen. Hello. Can I get my screen? Oh, thanks. Cool. Wonderful. The address bar is a bit small, so I'm sorry you're going to have a hard time to read it, but the URL is pretty easy to remember. It's utam.dev. I will share the link, obviously, in the resources. This is the main page for UTAM. It covers everything you need to know, downloads, the guide, and most importantly, tutorials. So there's a really neat user interface which helps you get your hands on very basic tests to try things. And there's a load of recipes or examples from the most simplest, that's what we're going to do today, we're just going to take a look at Hello World in this small example, to more advanced use cases. So how does this work? The interface is divided in a number of sections here. There's a documentation totally on the left side for you. And there is, on this side here, the definition of a page object, so JSON again. Below, there is your test code that is using the compiled page object, so the JSON here is turned into JavaScript here, or TypeScript, or Java. And then your test code uses this page object, and this is the page that we're testing. So this is a very simple page, just a bunch of divs with a span, and you can see some emojis here. And our end-to-end test is just going to test that we have the right emojis displayed here. So how do we do this? We first start by writing the page object. The page object here is the top-level page object. As I mentioned earlier, page objects are composable, so you generally have one for your top-level page, and then you have subcomponents. This one is root, so it's really at the top of the page, and then it can be composed with others. This particular page object is using the body of the HTML page as its root element, and then it has a number of elements. So this is the interesting part when you work with UTAM. You can declare elements on your page objects. You give them a name, and then you match them to some bit of CSS. So here it's a simple selector with the .world CSS class. And if we were looking at the source code of the component here, this has the world CSS class applied. So this is a quick way to access it. One last thing. There's a public property right here just after. And this is what allows the compiler to generate some objects from it. So you see I've named my element world. I can name it whatever I want. It doesn't matter. But in the end, when I have a name and a public true attribute here, it will generate for me a method. So you can see here, actually, no, it's here. I have now a getWorld method. So it transforms my JSON into a JavaScript object that I can use in my test. It will do get and then the name of the element as a method. So this is a very simple example, but it can do a lot more than that. It can work with composition, with arrays. It can also work with events. And in my tests, now that I have my page object generated, I can call getWorld to retrieve the element on my page. So here you see in the test code, this is a bit small, so maybe I'm just going to zoom out a bit so that we can read a bit more. In my test code, we first start to load the page, making sure that it's correctly loading. And then we call, from the root element, we call getWorld, and this will hook up to my CSS class world, and it will be able to extract the content. So I'm getting the DOM element, and then I can call a getText on it to making sure that I have the right emojis. Very simple example, but you don't see the full power of UTAM until you start working with composition. Because right now it's a simple page, but as it gets more complicated, think about, for example, using something in the Lightning experience. In Lightning experience, there are hundreds and hundreds of lines in terms of HTML, and it's a lot of composition. There's also another challenge when you work with Lightning experience. It's working with web components. Web Components has another particularity. It has something called the shadow DOM, which prevents you from doing quick searches from the root of the page. And with UTAM, you can actually drill down in subcomponents, passing the barrier from page object or from shadow roots. So that's quick intro to using UTAM. And now I'm going to take you through another example. So we're going to take a look at one sample app. Actually, let me show you the real app first, and then I can explain a bit what we're going to do as a test. Of course, I lost all my code, so let me just a second reopen my Scratch org. I'm going to use an application called eBikes. This is one of our sample applications that you can find online. I will share the link later on. And I've built a UTAM test for it, so we can actually see the source code of the test as soon as we're done with the presentation. And give me a second. I'm opening my Scratch org. I will show you the end user scenario that we want to test, and then I will show you the code that is involved and how we can test things. So, opening this thing quickly, getting there. Obviously, I lost my selection. E-bikes. So e-bikes is a fictitious electric bike manufacturer. This is a little simple page we've built called Product Explorer that simulates a search engine with a list of products, so bikes in this instance. These are all custom components built with Tiny Web Components. So the end user scenario that we're going to test is we're going to test how we can log in, navigate to the Product Explorer tab, do a little search there for one of the bikes. So I'm going to search, for example, Fuse, which is one of the model categories. So you see that it filters down my product list. I can select one of my products. Then I see the details of my product on the side. And finally, we end our test with this little icon there, which opens the record page for the bike that I've selected. Seems simple, right? However, you cannot simply test this with just tests, because there are a lot of components involved. There's interaction between the different components, and also you do not have access to the source code of the Lightning experience. So just test, for example, works, but you have to have access to the source code. And this test, I mean, it's just one of the many tests you would have to write to test how the end users will be using your application. So how do we translate that into UTAM? So I'm going to go back to the slides for a second before I show you the actual test being run. And I want to explain a bit how the page is structured, because it's important to understand the division of the different elements on the page. At the top level, we have the Lightning experience. So it is composed of several things. For example, the navigation bar, which contains the different tabs, and then the current Flexi page. That's the Lightning page that we're working on. And when we develop generally in the context of the Flexi page. We don't have access to everything that is above. And that's the hard part. We don't have the source code of everything that is above. We cannot easily navigate to this. But with UTAM, we have access to something called base page objects. So on top of the framework itself, what Salesforce does is that it provides a collection of base page objects for you. So it has already all the logic to navigate through the CSS and the HTML to get you started to get to the Flexi page. That's less things you have to do. But not only that, Salesforce also provides you with the base page objects for all the base Lightning components. So when you have a select, when you have a drop-down or a data table, well, Salesforce has already bundled for you a bunch of page objects so that you don't have to rewrite everything from scratch. So we're at the Flexi page level, but doesn't end here. There's a template. In our case, we have a 3-column layout, so 3 different regions. And in each of these regions, we have custom components. I've highlighted the custom components in orange. And these custom components use Lightning-based components. So things like cards, inputs, sliders, and a set of inputs. This is the filter that you have on the left side, if you remember, on the user interface. So it's a mix of custom components and a mix of base components. At the center, we have only custom components. I have a product tile list, which is composed of a series of product tiles. And at the bottom, we have a little paginator. For the sake of the demo, I will show you just one of the subcomponents because there's a lot of page objects involved in here. I will take the lowest one, and I think the paginator is pretty simple to understand. It has number, product, page X of Y, and back and forth buttons so that you can navigate in the list. And we'll see just that in the demo. And finally, on the right side, you have another product card with the detail of the product and a couple of base page objects. So that's the structure of the page. Now, all of these are web components, so remember that everything is isolated from the root of the page. If you are just doing a CSS query from the root of the page, or the top of the page, the body, you would not be able to drill down and get to the lowest level. And this is also where UTAM adds a lot of value, because it is allowing us to bypass all the barriers of the shadow roots of all the web components to drill down and get to the lowest level of detail. So let's see the test in action, and then I will show you the actual code for the test. So I'm going to go back into VS Code. If I start the presentation first. Oh, getting there. So yes, here it is. And what I'm going to do is I'm going to show you how you can run the test. So I'm going to start from, is it big enough? Well, let me actually increase a bit the font size. Yes. So the first thing you need to do when we run the test is start to compile our test object. I will go more in detail on the structure of those page objects. I'm just going to show you very quickly the page object. So here I'm drilling down the metadata of my org, my language components, and as I mentioned, we're going to take the paginator because it's a pretty simple component. It's a web component, so the typical metadata for web component. You'll notice that there's an underscore test, underscore folder. This is where we would have our jest tests. Again, I highly recommend to do jest tests. This is also JavaScript. This is unit level tests. And we have a new folder here called UTAM, and this is where we write our page object. So this is a pretty simple page object, just a couple of lines here. And what it does, it helps you grab a CSS element called navinfo, and it allows us to extract with a method here the content, the text content of this navinfo. So we can see how many products are selected, how many pages do we have. This is just one page object. In this example, there are tens of page objects. So the first thing we need to do before running our test is compile our page objects. And to do that, I have a series of scripts that I need to run. So what I'm going to do now is I'm going to compile those page objects. So I'm going to call one of my scripts, which is in fact calling UTAM behind it, the scene. I'm going to do test, do UI, and compile. And you'll see that it's going to transform a number of page objects. Let me actually minimize this so that you can have a better look. Here you'll see the page objects that I wrote. So I wrote a couple of them, and if you remember the diagram of the different page elements, there are a lot more elements than just these. These are the page objects I had to write, but I'm heavily leveraging the base page objects. So for example, when I have lightning cards, I did not have to rewrite the base page object for lightning cards. I had imported them from the Salesforce provided libraries. Same thing, there's very little on the Lightning experience side of things, because this is also provided by the Lightning base objects. So I don't have to handle with, for example, the logging page, stuff like that. This is all provided as part of base page objects. Now that my page objects are compiled, we can actually take a look at them. This creates for me a new directory. Actually, it's at the root of my project. There's a directory called page object, sorry. And you can see here it has compiled my page object, for example, the paginator. I have a definition for me generated in TypeScript, and you'll find the methods that I just shared with you in a JSON file, which are now turned into objects. There's also a JavaScript version with modules and without modules. In our case, we're just going to use the basic JavaScript version. So that was the first step, compile the page objects. The next thing I need to do is to get an authentication token. So I'm going to use a command that is pretty similar to what I had. Let me actually clear it out so that it's showing up higher up. I'm going to do another command called login generate. And this is using the Salesforce, no, it's the other way around, generate login. I always get myself mixed up. And what this does behind the scene is that it calls the Salesforce CLI. You see that this is just calling a Salesforce CLI, and I'm extracting the authentication URL so that I can log in my test. I'm saving it somewhere in a temp file, a .env file, and my test now can run. Final step, I run the test itself, and this is going to call WebDriver.io. So if everything goes well, we'll see a Chrome browser opening up automatically on my screen. There we go. And it will do the scenario that I just described a bit earlier. So it opens, navigates to the Product Explorer tab. Oh, it failed. So sometimes, depending on the network quality, it doesn't work. So I'm going to rerun several times. And that's an important distinction you have to make with unit tests. Unit tests work or don't work. Generally, you can rerun it several times. They have a fail or pass. But for UI tests, you'll see that there's a bit of randomness involved. There could be a little network delay that can crash the test. And I can assure that this test is designed to pass. However, with sometimes network delays, it fails. I wish I could show you it, because I just rerun it, obviously, before my presentation, and it passed. So it's a bit fragile, I would say. And when you work with unit tests, okay, one last time. It's too bad. Come on, be nice, demo god. Well, anyway, if it doesn't work, you'll still be able to run it at home because all of this is open source. Oh, this time it's working. Yes. So selecting, opening the page, filtering down with Fuse. Well, that was very fast. It passed. So again, what it did, it entered Fuse in the text search box, filtered the list, then it selected the first tile, made sure that it was properly selected, and then opened the record page. But you didn't see it because it was so fast. So that's how you run a UI test with UTAM. Now, we can take a quick look at the test itself to conclude this demo. So let me go back to my test here. So the tests are using something called Mocha. It's one of the many JavaScript testing frameworks. And I'm going to go over quickly the test. I don't want to spend too much time on this because this can be a bit complex. Here is really the part that is important for us, the description of the test scenario that I've shared with you all before. To test what I did, it took about 30 lines of code. It's 100 because there's a bit of setup before, but what it does is that it will manipulate the different page objects. So it started by loading the Product Explorer page, and we got a product tile list element that checked that we have the default pagination. So I'm running in a text test context, so I already know how many records there are in my environment. Obviously, for a more complex environment, you could have regular expressions making sure that the labels are correct. But in my case, I know already at first how many items are displayed by default. So by calling product tile list.get pagination info, it called my page object that was compiled, looked at the CSS reference, and extracted the text bit from the paginator. So that's the first thing we do. We check that we have all the elements displayed first before running our test. We also make sure that we have no selection on the card on the right side, making sure that the selection is empty. And then we really start interacting with the page. Here we use a product filter page object to retrieve a handle to the search input. So this is a text field. We're using a base lightning component. It's a lightning input component. We use set text to simulate keyboard typing so that we type Fuse. That was the name of the product brand. And then here what's interesting is that you've noticed that they have a lot of await statements in all of this. All of these tests are running asynchronously because there's a little delay. The page gets refreshed and we have to wait a bit. And that's actually what caused my test to crash a couple of times. Sometimes the network is a bit slow and sometimes we don't wait enough. So you have to work with timeouts. Maybe the result will never show up, and sometimes it does show up, but it shows up a bit too late. And here in this particular instance, we await for a page refresh, and we await for a specific element, the paginator text, to be updated and to show 4 items. So when we click on Fuse, there's a little delay because there's a request going to Apex, querying the database to retrieve the new product list, and returning the result to Lightning Web Components. Lightning Web Components re-renders, and so this is why we need to wait here for a specific refresh. So we made sure that we have a reduced list of items on our pagination. We are getting the list of tiles, the product tiles, the bikes. We grab the first one, so the first element, and we simulate a click on the first one. And we made sure that now on the right side, the product card is showing up the right product. So we know that Fuse X1 is going to be the first one because they're ordered alphabetically in my case. And finally, we click on the open record, which is a lightning icon on the upper right side. And we finally make sure that we have open the product record page with a regular expression check on the page URL to making sure that it's indeed a record page for the right type. So when you really look at the test code, it's pretty simple, and I think it's easy to write. And the other aspect to this is writing the JSON page objects. So it really boils down to this, writing a bunch of JSON, compiling it, and then using those modules in your test. Again, what's great is that they're reusable. You're reusing part of what Salesforce provides for the Lightning page objects. And if you have a team of developers, they can share those page objects. There's some knowledge sharing that is happening behind the scene. That's what is really powerful. All right, I'm going to end up with a few resources, and then I'm going to be taking questions after that. Okay, so this we already saw. Let's see if I can get quickly to the next slides. Lost my cursor. Oh, okay, I have to go through all this. Right. So we saw what end-to-end test is, but again, I want to always stress out the fact that you should shift left. Remember focusing more on unit tests because these are really less expensive to put in place. You can set them up on your own local machine, and of course, on continuous integration. UTAM, I hope I have convinced you today, is really a game changer here because it's something that makes your unit or UI test more robust. And it's also a great way to collaborate as a team, leveraging obviously the modular page object, but also the Salesforce provided base page objects. And I want to encourage you to try out the documentation. The website for UTAM Dev is really well written, and the playground, the interactive playground, is super fun to use and simple to understand. Some resources. Again, the URL for the UTAM website, utam.dev. I think it's simple to remember. And there are a bunch of sample repositories that I'd like to share with you today. I didn't show you all of them. I started with eBikes. eBikes is my little baby here. It's one of our sample assets we maintain. What I like about eBikes is that it's actually closer to a real-life application because there are a lot of different components involved and there's a bit more complexity. But if you want smaller examples, we have 2 additional repositories, UTAM.js repositories and UTAM Java repositories for small code examples with very isolated examples, both in Java and JavaScript. And that's a wrap with UTAM. I hope that you've learned something today and that you enjoyed the show. If you have any questions, I'll gladly take them. Sure. Can you pass it behind? Yeah, behind. Sure.
Yeah. I want to know if it's only available for Lightning component, or it can be used for Visual Force or whatever.
It's a great question, and actually I completely forgot to mention this. Yes, UTAM is open source and it works with any technology. So you can even test a React application, you can test a mobile Android application, you can test whatever you want. The great value of UTAM is that you do not need to have access to the source code of what you're testing. So if you have even packages, like a package from the App Exchange, you can include it in your end-to-end test. Doesn't matter in which language it is written. So yes, you can pretty much test anything.
So we can test a public Visual Force with that.
Absolutely.
So no need to generate token to connect. It will be automatic.
It's going to be. I mean, it's going to be on the Lightning page, on the Lightning experience, right? Or
no, it will be a site, for example.
Yeah. Well, you can use it. Yeah.
And the second question: can you imagine to use that to schedule a test in live, for example, in the production?
Yeah.
And to report in case of failure?
You wouldn't really test directly in production because remember that all you do is modifying records, so it's a bit dangerous to do that in production. But you could do that in a full sandbox if you wanted to, yes, for sure. And what I shared today was using something called the, it's a Chrome, but it's visible, it's running on my computer, but you can run the same tests in a headless mode, so without access to a screen. So that's typically what you would schedule in a continuous integration environment. Now, the only problem with that is that you see the test is a bit fragile, so it will work, it will fail, it's kind of hard to get predictive results. Generally, when you run end-to-end tests at scale, you're looking more at trends. So you run maybe hundreds of tests, and you're looking at several iterations, see what are the tests that are constantly failing, and maybe these ones are the ones that are broken. It's not like unit tests. When you see a unit test that fails, generally, but it's broken forever, it's not going to fix itself by magic. So,
but how to schedule a test and to notify in case of failure?
Well, it's just going to be part of your different CI jobs, and your CI system is going to run that test and report based on whatever rules you set on your CI system. UTAM itself will not notify you, but it's going to return in the end a test result like we saw in, sorry, if I can close the presentation mode, like we saw in when I ran it in my, let me reopen back my terminal. Oh, where is it? I think I closed it. Maybe I close it. But in the end of it's a shell command. So if there is a status reported at the end, it will generate also a test report. And you can analyze this test report pretty much like you do with unit tests. And you can extract some statistics out of it. After that, it's just a matter of configuring your own CI system to send alerts whenever you want.
So I cannot do that with Salesforce. I need to have an external.
Not natively.
Yeah.
No.
Okay.
The UTAM does not run directly on Salesforce. It's running on my machine, on Java or JavaScript, but not directly in Salesforce.
Okay, thank you.
Sure.
So you showed you had hard-coded data in your test. Is
Yep.
there a way to generate test data for your UI tests?
Yeah, obviously you could. So what you would do is you would have a bit more complex environment because you would be combining this with some preparation scripts. And typically using the Salesforce CLI is a good way to do that. You would inject some test data. And in fact, when you work with e-bikes, all the data comes from some test data. So there's a plan JSON file with a bunch of custom accounts, custom products, all of that. And it's all bundled with some ready-made data. So you know exactly what is going to be there. So you can either do this, because this is a small example on a scratch org, but if you work with a sandbox, you can have more complex setup with additional tools.
So I think also in the beginning you mentioned Selenium. So can you talk a little bit about that? Does this completely replace Selenium? You have to choose, or is it something that you would combine?
So yeah, generally it's two different approaches. Selenium is more like recording user actions, so it's more declarative, and this one is definitely code focused. So it's kind of a tough choice, but you'll have to choose either path, one or the other.
But you could have a complete testing strategy based on this, plus your unit testing.
Oh, you could do both, yes, of course, but it's just going to be kind of expensive to maintain, I think. If you just, I mean, a CI system is already complex enough. If you start like duplicating all the amount of tool you have, it can be a bit risky, unless you're very, very, have a lot of constraints on your test and it's super important for you. It may be a bit expensive to do all of that, to multiply the tools. Cool. Well, thank you. I'm staying here, so if you want to have additional questions, feel free to come over and say hi. Thank you.